Hello friends, in this video we are going to discuss the successive approximation type digital voltmeters. Okay, so here we are having a block diagram for successive approximation type digital voltmeter. So in this block diagram, here input voltage is the unknown analog voltage, okay, and here output is the digital output. As the this is the digital voltmeter, so expected output is the digital one, okay. So this is the analog input voltage, which is the unknown one, and here we will be getting the output in terms of the digital form or the digits, okay. Next, here we are having a reference voltage ER, okay. Reference voltage is ER. Next, here we are having the voltage divider circuit, okay. So as this voltage is the analog voltage, okay. So therefore here available voltage, by using the voltage division rule, available voltage here will be having the analog voltage only. This voltage comparator block compares the unknown voltage and this reference voltage, some part of the reference voltage, okay. Now here I have shown it as a electronic switches, okay. So how these electronic switches works, we are going to discuss, okay. So first of all, voltage comparator compares the input voltage and the reference voltage, okay. So in successive approximation type digital voltmeter, okay, so here first comparison will be between the unknown input voltage and the 50% of the ER, okay. So if unknown voltage is greater than that of the 50% of the ER, accordingly the voltage comparator generates the output, and accordingly the programmed switches will be, yes, programmed switches will be adjusted and it will be giving the output, because here we have taken the feedback, okay. So due to that, those electronic switches, again this voltage we are going to vary, okay. Electronic switches will vary this voltage, means it is like a closed loop type system, okay. So it is like approximation, they have used the word, okay. So let us discuss how it works, okay, how it works. So here this converter compares the analog input to a decade assembly counter, that is the DAC reference voltage, okay, means it is the analog input voltage to this reference voltage it is comparing, okay. Reference voltage which is repeatedly divided in half, okay. So which is repeatedly divided in 50%, okay. And the process here we are having like this is the process actually, okay. This is the process, means how it works. So as I said, ER is the reference voltage, okay. So for 3-bit conversion, okay, so for 3-bit conversion, here we are having ER is equal to 1,000, that is the reference voltage is 1,000. Similarly for 2-bit, okay, we'll be having the reference voltage as 100, okay. So for 3-bit it is a 1,000, for 2-bit it is a 100, right. For 4-bit it is a 4 times 0, okay. So it is like a reference voltage we need to select, okay. Next, so as I said, this is the 3-bit comparator here we have shown, okay. 3-bit digital voltmeter we have shown here, okay. So 3-bit means which are the possible outcomes it will be giving, the output like 000 to 111, okay. These are in binary forms, okay. We can find its decimal equivalent also, okay. So first thing is for 3-bit voltmeter, yes, reference voltage is 1,000, okay, 1,000. Next, first comparison, yes, it will start with 1/2 ER, that is a 50% of the reference voltage, okay. So here 1,000 is nothing but decimal equivalent is 8, okay. Decimal equivalent is 8, okay. So what is the 50% of this 8? It is a 4, okay. So in binary it will be 100, okay. So first of all, the unknown voltage here, this input voltage, that is the unknown voltage, will be compared with the 1/2 ER, right. So here in order to get 1/2 ER, definitely this pointer, right, this switch will be at the midpoint of this resistor, then and only then we'll be getting it as a 1/2 into ER, okay. So this voltage comparator will compare 1/2 ER and the input voltage, okay, and the input voltage, right. Next, so here So here comparison will be done between the 1 by 2 AR and the analog input voltage. Okay, and if the result of this comparison shows that first approximation, that is the first comparison, okay, output of the first comparison, that is the first approximation, is too small, that is 1 by 2 ER is smaller than the unknown voltage. If 1 by 2 ER is smaller than that of the unknown voltage, then what will happen? And for the next comparison, it will compare that unknown voltage with the 3 by 4 ER, with the 3 by 4 ER. So are you getting the point? So first of all, it will compare the unknown voltage with the 1 by 2 ER, and if 1 by 2 ER is lesser than that of the unknown voltage, then it will compare with the 3 by 4 ER. Okay, suppose if 3 by 4 ER is again lesser than that of the unknown voltage, right, then it will compare with the 7 by 8 ER. It will compare with the 7 by 8 ER. Okay, and like this we will proceed. Okay, we will proceed. Or if you check in the second case, if the unknown voltage is less than the 1 by 2 ER, I am saying if unknown voltage is less than the 1 by 2 ER, right, then the tree will proceed in the downward direction. Okay, so if it is less than that of the 1 by 2 ER means, yes, again at the next comparison the unknown voltage will be compared with 1 by 4 ER. Okay, and likewise it will proceed. So if you check here, first of all, reference voltage is divided with 150%. Okay, next this 50% and the reference voltage. Okay, so here the remaining 50% it will be again divided with as 3 by 4 ER and 1 by 4 ER. Again it is divided as 7 by 8 ER and 5 by 8 ER. Okay, so it is like an approximation only. Okay, so in order to get the final value, yes, how many comparisons we require? We require 3 comparisons, right? One, second, and this is the third comparison. Are you getting the point? Okay, so in this way actually it proceeds. Okay, so for 3-bit number we require 3 comparisons. Similarly for 4-bit number, how many comparisons we require? We require 4 comparisons. Okay, and if you check here, yes, so as it is given, it has a electronic switches. Okay, so this will be controlled, right? This voltage, that is the second input voltage of the voltage comparator. One is the fixed, that is the input voltage, unknown voltage. Okay, and the second voltage, it will be decided by the electronic switches, and according to whose direction these electronic switches will operate. These electronic switches will operate according to these programmed switches, and this programmed switches is nothing but the logic circuit, and this logic circuit is having the logic whatever the shown here. Are you getting the point? Okay, so first of all, this voltage will be 1 by 2 ER, right? This voltage will be 1 by 2 ER. After that, suppose if the unknown voltage is greater than the 1 by 2 ER, then the next voltage will be 3 by 4 ER. Okay, so here we will be getting again 3 by 4 ER. So it compared with 3 by 4 ER and the unknown voltage. Okay, and likewise it proceeds. Right? Are you getting the point? Okay, so this is about the successive approximation type digital voltmeter. Thank you.